All right, so today we're continuing on with section 11.1. Yesterday we really worked towards evaluating exponential functions and graphing them. Today we're going to move on to solving exponential functions. So an exponential function, remember, is a function with a variable as an exponent. So the idea here is we have to figure out 2 to the what power equals 64. Now remember, since this is a power, the idea is how many times would I have to multiply 2 by itself to get 64? So if I did 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So we had to multiply 2 by itself 1, 2, 3, 4, 5, 6 times to get 64. And now when I look back at my original equation, my exponent was the x. Well, now my exponent is 6, so I know x has to equal 6. But if I look at the next equation, I can't really do that same thing because there's variables in both exponents. So that means we have to think about things a little differently. So this one-to-one property is the idea that our goal is to make the bases the same. Our goal is to make the bases the same. Because if I make the bases the same, it'll be easier to do these types of problems. What I mean by that is this. So let's rethink this more simplistic problem. 2 to the x power equals 64. Well, the base on this first one is 2. The base on the next one is 64. If I can make the bases the same, then it'll be easier. Well, I'm not going to change 2 into 64 because that makes the number bigger. If anything, we want to make our base smaller. So can I change 64 into 2? Well, yeah, we just figured that out, right? Isn't 2 to the 6th power the same as 64? And then my other side is still 2 to the x. So now that my bases are the same, if I'm going to have both sides equal, then the exponents would have to be equal since the bases are equal. So x equals 6. So that's our goal. We want to make the bases the same, because if we make the bases the same, then the exponents will have to be equal as well. Okay, so that'll be our goal in this next problem here. We're going to want to make our base numbers the same, 3 and 81. Well, I'm not going to change 3 into a bigger number, but can I change 81 into 3? Does 3 to any power give me 81? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th power is 81. But then we still have this x plus 3 that was the original exponent that has to come along with it. And my other side, the base was already 3, so it's good as it is. Now, we also need to remember this idea that a power to a power, that property that we dealt with before, power to a power or exponent to an exponent, however you want to think about it, means that you have to multiply your exponents. So really, this is 3 to the 4 times x plus 3, because we're distributing this into the parentheses, so we multiply our exponents. Now when I look at this problem, our bases are the same because they're both 3. So if our bases are equal, then in order for both sides to be equal, the exponents have to be equal. So we can go ahead and now solve this equation. So we distribute in to get 4x plus 12 equals 2x. Subtract the 4x. So we would have negative 2x equals 12, divide by negative 2, and x equals negative 6. Now I would recommend that when you get to an answer that you go ahead and check it in your calculator. So we're saying x is negative 6, so I'm going to plug it into this original one. So 3 to the 2 times, now we're saying x is negative 6, gives me this number, and then I'd go ahead and do that with the other side as well. So 81 to the, my x was supposed to be negative 6 plus 3. And since these are equivalent, that tells me both sides are equal. So yes, x equals negative 6 is your answer. I highly encourage you to always check your answers because it's a really easy way to make sure that you get the right and correct answer on quizzes and tests. All right, so we're going to write down those steps that we just took here as we do one of the sample problems. So step 1, remember the idea is right now I can't solve this because the bases are not equal. So my first step would be to make both bases the same or equal. Little reminder, so remember that an exponent to an exponent, or a power to a power, means that you multiply, right? Keep that separate from that. So here, I'd want my base to be 5, because I can't change 5 into anything smaller, but 25 I can. 5 to the second power is 25. But the problem is we don't want it to be 25, we want it to be 1 over 25. So remember from yesterday that idea of if we want to move something into the denominator, really we have to start out with a negative exponent. Because remember, something like 5 to the negative 2, to make the exponent positive, we'd put it in the denominator. And 5 to the second power is 25, so this would be 1 over 25. So if our goal is to change its position into the denominator, we just need to make our exponent negative. So this equals 5 to the x. So now our bases are both 5, so we've done step 1, which is to make our bases the same. Once our bases are the same, we can go ahead and set our exponents equal. So in this case, x equals negative 2. Now our third step we don't really need to do this time, which is to solve for the variable. But I would also recommend in this step that you check your answer with your calculator. So I will do that step. So 5 to the now x, which we think is negative 2, would give me 0.04. 1 divided by 25 is the other side, which is also 0.04. So I know that, yes, x equals negative 2 is my solution. All right, what I'd like you to do right now is pause the video and try example 2 on your own. Once you finish, start playing the video and check to see that you've done it correctly. All right, so in this case, we have a 3 and a 9 as a base. So I'm not going to change the 3 because it's already as small as it can get, but I can change the 9 into a 3 because 3 to the second power is 9. And now the other side is 3 to the x plus 1. So when I look at this, my bases are the same. So if my bases are equal, then I know my exponents have to be equal. So 2x plus 1 equals 2. So we can go ahead and solve that. Subtract 1. 2x equals 1, divide by 2, and x equals 1/2. Okay, and you could go ahead and plug that into your calculator to check it, but that one does work. All right, number 3. My issue with number 3 is the fact that this is a decimal, and I don't know how to deal with that. So if I were you, I would make this a fraction first. Okay, so you can use your calculator, math, fraction, type it in, and it would be 1 over 1, 2, 3, 4, 5. So it's 1 over 10,000. Okay, so 1 over 10, not 10,000, 1 over 100,000, sorry, I misspoke there because there were 1, 2, 3, 4, 5 here equals 10 to the x power. And really, I'd have to multiply 10 by itself 1, 2, 3, 4, 5 times. Which would give me 10 to the 5th power, right? Because there are 1, 2, 3, 4, 5, 0, so 10 to the 5th, but I want it to go into the denominator, so we'd put a negative, equals 10 to the x. So now again, our bases are the same, and if our bases are the same, then we can set our exponents equal. And again, I would recommend checking this in your calculator. So 10 to the, oops, wrong button, 10 to the negative 5 gives me 1e to the negative 5, and then 1 divided by 1, 2, 3, 4, 5. Same answer, so I know that x equals negative 5 is correct. All right, so let's look at the back side. Example 4. This one is actually one that we're going to make a try on your own, and that we'll check tomorrow together in class. Okay, but let's look at number 5 together. Now 5 is a little bit more complicated because I can't change 9 into 1/3 and I can't change 1/3 into a 9. So I'm actually going to have to change both of these bases into a common number, and the easiest one would be a 3. So the idea is 3 to what power would give me 1/3? Well, remember, we talked about the fact that if you want to move the number to the denominator, you have to have a negative exponent. And since I don't want to actually change the number of 3, I just want it to move it to the bottom, it'd be to the -1. And then this is all to the 4x power like it originally was. Then we have to think 3 to what power would give me 9? Well, 3 to the 2nd power would give me 9. And remember, an exponent to an exponent means you're really multiplying them. So this is 3 to the -4x equals 3 to the 2nd. So now that my bases are the same, we can set our exponents equal. So -4x equals 2. Divide by -4, and x would equal -1/2. And again, if I were you, I would plug that in here and check to see that you get that same answer on the other side. So you could either type this in using your fraction button, or you could type it in using parentheses and just 1 divided by 3 to the, now my exponent is going to be 4 times -1/2. Which is 9, which matches the other side. So we know that's correct. Again, example 6 is going to be a try on your own that we'll check tomorrow in class. But we're going to do number 7 together. And the reason why is because of this absolute value. But don't let that absolute value throw you, okay? Because the idea is still the same. So my base is 4 here, my base is 4 here. Or I'll need to make my base 4 here. So 4 to what power is 64? Well, 4 times 4 is 16, times 4 would give me 64. So 4 to the 3rd power is 64. And then we have 4 to the 3x minus 6 in absolute values. So again, my bases are the same. So all I need to do is set my exponents equal. So that would be the absolute value of 3x minus 6 equals 3. Now remember, when we're dealing with absolute values, the idea is what number would go in here to give me 3? Well, the absolute value of 3 is 3, and the absolute value of -3 is also 3. So that means we're going to have to split this into 2 different equations. 3x minus 6 equals 3, or 3x minus 6 equals -3. Either one will work, okay? Because if we put a -3 in here and take its absolute value, we will also get 3. So we're going to solve this. So add 6. 3x equals 9, divide by 3, x equals 3, and we're going to do the same thing here. So add 6, and we have 3x equals +3, divide it by 3, x equals 1. So these are our 2 solutions. So remember with absolute values that you're going to need to split it up. All right? And the last ones. Sometimes when we look at these problems, we're going to need to do extra steps first. Now, example 1, this one's one you're going to try on your own after I show you how to do number 2. So that one's one we're going to check in class tomorrow. So this one is telling you f of x is equal to 1/16 to the x power. And here they tell you f of x equals 8. So you need to be careful with this. If they're saying f of x equals 8, they're saying I need to replace f of x with 8. So 8 is going to go in place of the f of x. So really this is saying 8 equals 1/16 to the x power. All right, so now I need to try to make common bases. So I would start out thinking, can I do 8 to some power to get 16? Well, 8 to no power gives me 16, so that's not going to work. So what would be a common base that I could get both of these with? So I would try 4 first, because I know 4 to the 2nd power is 16, right? But does 4 to any power give me 8? Well, no, because 4 to the 1st power is 4. Then we go straight to 16, so that's not going to work. So then what other numbers can I use? What number can give me 8? Well, isn't 2 to the 3rd power going to be 8? So that works. And 2 to what power is 16? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 4 of them would give me 16. So I'm going to change both of these bases into 2. So 2 to the 3rd power is 8. 2 to the 4th power is 16. But remember, we want to put it in the denominator, so it's going to be a negative. And then all of that is being raised to the x power. Power to a power, we multiply. So this is really -2. Or sorry, not -2. 2 to the -4x equals 2 to the third. Now that my bases are the same, we can set our exponents equal. So 3 equals negative 4x. Divide by negative 4. X equals negative 3/4. And you could go ahead and type that in your calculator and check the answer. But that's the end of the notes for today. Tomorrow, you're going to need to go ahead and make sure you try all 3 of those, and we'll go over them together in class.